This is the U-Substitution video 3. These are specifically trigonometry examples of U-sub where there is trig. If you would like to see other U-sub examples, I have 2 previous videos, so feel free to go check those out. So this video assumes that you know basic integration techniques, including your integration rules for trig. So let's get into this. So starting with number 1, a lot of times if your argument, so meaning cosine of what, if your of what is something other than x, a lot of times that's going to be your u. So let's make u equal to 3x. du, take the derivative, is going to be 3 dx. Like we've talked about in previous videos, I have dx, but I want 3 dx. And we've said I can't just multiply by 3 because that changes my problem, but I can multiply by 1. So strategically, I'm going to multiply by 3 times 1/3 because that equals 1. So I'm going to multiply by a 3 right here because that helps me, but I'm also going to multiply by 1/3 out front. So keep in mind, by doing this, I'm not changing my problem. So now I want to write everything to be in terms of u. And from here, I know how to integrate cosine of u. So the integral of cosine is sine. Don't forget your plus c. And I want my final answer to be in terms of x, so put that 3x back in there. And that is our first trig example. Okay, let's do another one. So very similar, but now we've got a pi in there. So I'm going to make u equal to pi t. That means du is pi dt. So similar to the previous one, I have dt, but I want pi dt. So I can multiply by pi there only if I multiply by 1/pi somewhere else in my problem. Let's rewrite everything to be in terms of u. I have 1/pi, and then I have the integral of sine of u du. Now the integral of sine is negative cosine. So I'm going to put the negative with the 1/pi, but then I have cosine of u plus c. Last step, we want everything to be in terms of t. So put that pi t back in there. And there's our answer. Let's do another one. Okay, next one. Notice your argument is the square root of t. I have cosine of the square root of t. So let's make u equal to the square root of t. I know how to do cosine of t, but not cosine of the square root of t. So take your derivative, du, keep in mind square root of t is t to the 1/2. So I have 1/2 t to the negative 1/2 dt. And if I rewrite this, this is 1/2 times the square root of t. And notice that we have a rad t in a denominator already. So I'm going to rewrite this one more time. I'm going to move my 1/rad t next to my dt. Now I want 1/2 rad t. Keep in mind, this is me multiplying by 1/2. So I'm going to multiply by a 2 out front. Now I can rewrite everything to be in terms of u, cosine of u du. So the integral of cosine is sine, so 2 sine of u plus c. Substitute back in 2 sine of the square root of t plus c. We've got a few more examples. For the next one, if it helps, you can rewrite this. Sine 6 raised to the 6th of theta is the same thing as sine of theta raised to the 6th. We just write it like this just as a custom. But if it helps you, feel free to rewrite it like this. They mean the exact same thing. So notice I have sine raised to the 6th power. That's your clue that u is going to be sine of theta. Now derivative of sine of theta is cosine of theta, so du is cosine of theta d theta. Notice that you have your u already in your problem. So we can rewrite it one more time if you want, or if you feel comfortable, you can skip this step. But I'll rewrite it just in case that's helpful. So I have my u and I have my du, so we can rewrite this. And then we can integrate u to the 6th. This is going to be 1 over 7 u to the 7th plus c. Put your sign back in there. And while this is right, I would say no one really writes it that way, so I would rewrite it sine raised to the 7th of theta plus c. Let's do another one. Okay, so we have a couple things going on. So I have cotangent of theta under a radical, so that's one clue that cotangent maybe should be u. Another clue is you can notice that the derivative of cotangent is negative cosecant squared. So you can think ahead and think, over here I have my du happening. So u is cotangent of x. Take the derivative of cotangent, we get negative cosecant squared x dx. So I'm super close to my du right here. I just need to multiply by a -1, which means I also want to put a negative out front because I need to multiply by 1. So I can rewrite to be in terms of u. And I'm going to rewrite it one more time. Square root of u is the same thing as u to the 1/2. And then we're ready to integrate. So I have my negative, 1/2 plus 1 is 3/2. Flip the fraction, and then don't forget the plus c. Last step, put your cotangent of x back in there. And we have our answer. Okay, so next we have the integral of cotangent of x. Now, we don't have a rule for this one. Like up here, we know that the derivative of cotangent is negative cosecant squared, but we don't have a rule for the integral of cotangent, or at least maybe we don't yet. So for this one, this is a U-sub problem, and the trick is rewrite cotangent of cosine as cosine of x over sine of x dx. And now see what you can do. Now I would say sine is in a denominator, so let's make u equal to sine of x. That means du is cosine of x dx. And notice that du is already in your problem. So we can rewrite it one more time to make it make more sense, hopefully. I have 1 over sine of x, and then I'm going to move my cosine of x over. So when I rewrite in terms of u, I have the integral of 1 over u du. I do know how to integrate 1 over u. That's natural log of the absolute value of u plus c. From there, I want to be in terms of x, so I'm going to replace u with sine of x. And now you do know the integral of cotangent of x. Okay, let's do one more. All right, so I have secant cubed, and then I have tangent. So since secant is being cubed, that's kind of your clue that you want u to be secant of x. Now the derivative of secant of x is secant of x tangent of x. So I'm going to get secant x tangent x dx. So I'm going to do a little bit of maneuvering because I have tangent of x dx, but I want secant tangent dx. So instead of secant cubed, I'm going to make this secant squared x. And then I'm going to have secant of x, tangent of x, dx. So notice I can put my u, and then I have my du. So I'm going to rewrite this. This is u squared du. I'm ready to integrate. This is u cubed 1/3 out front plus c. Last step, put your secant back in there. 1/3 secant cubed x plus c. And those are some U-sub examples with trigonometry.